All right, so we are getting into rational expressions now. And in order to do this well, we got to go back to factoring. So you guys have been factoring since grade 9 or grade 10, right? Every year it comes up. So we're going to go over this again because, yeah, kids forget. But to tell you the truth, for this unit, if you don't have factoring down, you're going to be in a world of trouble. Because that's pretty much the start of every question. We just like factor everything, and then we're going to cancel stuff. But if you can't factor, you just can't really do any of these questions. So like really make sure that you get the good grasp on this factoring now. So okay, so I'm gonna go just examples kind of quick. Like I said, I'm gonna like leave this for you guys to look through. So make sure you look through it, like if you're doing your questions for references. But I'm just gonna do some of these examples. So it says factor the greatest common factor from a polynomial. So that's one type of factoring. So I'll give you guys a different example. So let's say we had 4x minus 16. Something like that, right? So now, this one's actually the easiest type of factoring. This is the one where we want to factor something out, right? It's like, I always think about it as like pulling a number out, like pulling it out to the left there. But really what we're doing is we're figuring out the number, the greatest common factor that goes into 4x and 16. And the way we do this, yeah, we just kind of like look at the numbers first and then the letters, right? So let's look at the numbers. What's the biggest number that goes into 4 and 16? Yeah, you guys are doing that, right? So then we write that down. We write down the greatest common factor. So it would be 4. Then start a bracket. And then we write what we have left after we divided out that 4. Because that's what we're doing, right? When we're pulling it out, we're really dividing out that 4. So we're going to go, okay, 4x divided by the 4 I took out. What would that be? Yeah, just x, right? It's like 4 divided by 4 was like 1. So it's like it canceled, right? There's like not there anymore. And then the x is still just the x, right? Nothing happened in that. There's nothing to divide there. And then move on to the next one. So then minus, and then 16 divided by the 4 I took out is 4. And there you go, factored. Okay, well, these ones aren't too bad at all, and then they can just get more complicated. So there's a good example there you guys can use for your reference, but let's do another one. So let's say we had 3a to the 3, b to the 4, minus 12a to the 4, b to the 2, plus 18a squared b to the 3. And I said we're going to factor this one. Okay, these ones usually I find are the most intimidating. Like you look at it and you're like, oh my god, like there's so many letters and numbers going on here. I usually find like the more complicated it looks, the easier it is to do. So these really complicated ones, it's the same as the last one we did. There's just going to be more steps. So we're just one by one, right? We're going to go through, okay, look at the numbers first. What is the biggest number that goes into all those numbers? 3, right? So write it down. We write down our greatest common factor. And then move on to the a's. So now, of all those a's, what is the biggest a that goes into all of them? A to the 2. Yeah, it's like the smallest exponent is going to be the one that goes into all of them. So it'll be a to the 2. And then b to the 2. Yeah, b to the 2 from this one, right? That was the biggest exponent. And then just like above, now what's our next step? We would write a bracket and then write what we have left. So now we're just going to go through each one of them. So from this one, 3 divided by that 3 we took out, it's like canceled, right? So that's like, you can put a 1 if you like, but we don't typically do that. Okay, and then with these ones, a to the 3 divided by a to the 2 that we took out, it's just a. And let's just take a minute to talk about why that is, right? Just with exponent laws, it's really like a to the 3 divided by a to the 2. We subtract the exponents, right? You are good at this. So that's a to the 1, right? So if I would have had, yeah, a to the, well, here, we'll keep going. We'll do other examples. You guys will get it. So then b to the 4, dividing out that b to the 2, that would be b to the 2. Okay, and then move on to the next one. minus 12 divided by the 3 we took out. It's 4. A to the 2. What happens there? They cancel, so there's no more b in that one. And then plus 18 divided by the 3 we took out. 6. That took a little too long. A to the 2 divided by the a squared that we took out. Just cancel, right? And then b to the 3, so that's just b. Close your bracket, and that is factored.
Okay, so what's the catch?
That's not, there's nothing. Yeah, it's gonna get, it'll get a little harder. So that's that one type, right? So let's keep going to the other types here. So factoring a trinomial is the next one. And these ones are a little tougher, but they're not bad either. You guys will get the hang of this, I'm sure. Okay, so it takes the form of x squared, like it'll be x squared plus some number x, and then plus just some constant on its own, some number on its own, right? Okay, so let's say I'm gonna like do this question to see where this comes from, right? If we had the situation where we had x plus 2 times x plus 3, and I asked you to like expand this. Yeah, you guys would be thinking that foil, or I call it the rainbow sometimes, right? Really what we're doing is we're going to take this front term and we're going to multiply it by both of those. Oh, that was not good. That was worse. Okay, and then the 2 would be multiplied by both of those, right? Okay, so if we did that, that would be x times x, like the first one would be x squared. And then x times 3 would be 3x. And then 2 times x is 2x. And then 2 times 3 is 6. And then just careful, we're not quite done. What would we do with those? Yeah, combined like terms there, right? So then this would be x squared plus 3x, or sorry, plus 5x plus 6. Okay, so why I did that was because when we factor things, right, what we're doing is we're going to take this thing we have and we're going to try to get that back out of it. Right, where it's like doing that in reverse is what factoring really is, right? We want to have something times something, like this factor, right, x plus 2 times x plus 3. Factors are something times something else, right? So there's 2 factors sitting there that are multiplied by each other. Okay, so if we were going to go in reverse, I think the quick and easy way to do these ones is going to be just, so I'm just going to write it down myself again. Yeah, exactly. Nice. Yeah, so when we get to this point and you see it's one of these style things we're factoring, you can throw your brackets down. And then they're both going to get an x. And that has to be the case, right? Because if I expanded this all, at some point I'm going to have to go x times x to get this x squared, right? So this is why this is going to work, just to write down the x and the x. Now, like you guys were saying, I just got to figure out these two numbers, and these two numbers just have something to do with the 5 and the 6, right? These two numbers need to multiply. I'm just going to put m, so multiply to 6, and they have to add to 5. So then
always be like from the right side will multiply, the middle will add.
Yep. Yep. Exactly. And really, let's go back to why that is. Looking at our example, right? The numbers that we're looking for here were 3 and 2. Do you guys see the pattern here? That 3 and 2 multiplied to give us 6. And then when we collected like terms, we added those to get that middle number. Right? That's why they have to add to the middle numbers, because when you collected like terms, that's what you were doing. You were adding them. Yeah? So that's why we're doing this method. Okay, so numbers that multiply to 6, add to 5. 2 and 3, yeah. So 2 and 3. Right, and normal in other questions we'd have to figure out, okay, which one's positive, which one's negative. This one, they're both positive, so that was pretty easy. And does it matter if it's x plus 2, x plus 3, or x plus 3, x plus 2? No, doesn't matter, right? They're gonna be written in either way. It's like 3 times 4 is the same thing as 4 times 3. Multiplying doesn't have an order. Okay. So Okay, let's do, I'm going to give you guys one more of these just because they can be a little tricky. Let's go x squared, what are we thinking here?
Where are we doing this?
Minus 3x, yeah, I'm going to get you guys to this in a second, minus 18. Okay, so for this one, guys, the way I kind of do this is I would just, for a second, ignore the negatives and just say, okay, what are some numbers that multiply to 18? So maybe I go like 18 and 1. Is there any way I'm getting from 18 and 1 to 3? Like if I went 18 plus 1 or 18 minus 1, there's no way I'm getting to 3, right? Or maybe 9 and 2. So like 9 and 2, but is there any way I'm getting from, no. What about 6 and 3?
Not really.
Yeah, like 6 minus 3 would get me to 3, right? So there's a potential here. So let's go, okay, 6 and 3. And then I'd say, okay, well, I need to multiply to a negative number. Well, you can only multiply to a negative number like one way. Well, it's technically two, but like one's got to be negative and one's got to be positive, right? That's the only way this is going to work out to give you a negative.
Does it matter though?
Well, yeah, it will matter. So the good news is we've kind of narrowed it down. We got 50-50 chance, right? If one's negative and one's positive here. So let's say that I was like, all right, 6 and negative 3. But now 6 and negative 3, okay, they multiply, positive 6, negative 3 multiply to negative 18, so good. 6 minus 3 is positive 3. Okay, so that's wrong, right? So I got an easy fix. I just need to swap those things around. So minus 6 and positive 3. So now negative 6 plus 3 would be negative 3. Yeah? Okay. All right. Let's move on. Okay, difference of squares type of questions. So these ones are actually probably the easiest one to factor if you recognize it when you see it, right? That's kind of the hardest part of this one. These ones take this form. If we have something like, well, here, you know what? I'm going to do it in reverse for a second. Let's say if I had x minus 2 times x plus 2, and I expanded this thing out, well, that would be x squared plus 2x minus 2x minus 4. And do you guys see that the middle terms there would cancel? Like 2x minus 2x, they would just cancel. So this would be x squared minus 4. Now, why I did that was because, can you guys see that this is a perfect square and this is a perfect square? Right? So yeah, we're gonna just, so there's a nice way for us to get to ones that are in this form where it's perfect square minus a perfect square, right? A difference of squares. Get from this one to back to the original, and we just do it this way. If you write down your brackets, they both, and then the way this works is it'll be the square root of the first one goes into both these spots. So the square root of x squared would be what? Just x. Yeah, x and an x, which makes sense, right? That's how we get that x squared out of that, right? X times x. And then it's just one's a minus, one's a plus, and then the square root of the other number. So 2. So 2 and 2. Makes sense? They're really quick and easy. Let's do another one. What if I had 64 x to the 4 minus 9y squared? See, like I said, this is one where it'd probably be hard to recognize it, but all of those things in there are perfect squares, right? 64 is a perfect square, x to the 4 is a perfect square, 9 is, y squared is. They're all perfect squares, and we're taking the difference. So we can do the same little trick here. Write down our brackets. The square root of 64 is 8, so they both get an 8. The square root of x to the 4 is x to the 2, and maybe you need a refresher on that one. X to the 2 times x to the 2 is x to the 4. So right, so something times itself gave us x to the 4. So it's going to be x to the 2 would be the square root of x to the 4. Exponents, yeah, and this will always be the case with these ones. If I had x to the 6 and I said, what's the square root of that? It'd be x to the 3. You guys see the pattern? It'd always be half with the exponents there. Okay. Anyway, so x to the 2. X to the 2. One's a minus, one's a plus. And then square root of 9 is 3, so they both get a 3. Square root of y squared is y. There you go. Not too bad, if you know what you're looking at. All right, now so there I'm gonna